Hi everyone, this is a short video, a continuation of the previous video about exponent rules. This video will deal with the power rules and also combinations of all of the rules together, sort of an idea, order of operations and things like that. So the power rule basically goes like this, that if I have something to a power raised to another power, I can multiply those two powers together, and that's what we get. So, of course, the base doesn't change here. This can happen even if our base is numerical. For the second power raised to the third power would be 4 times 3, would end up being 4 to the sixth power. So we just multiply the powers together. So this can even happen if there are multiple things within the parentheses. Now remember, this is 2 to the 1 power, so this becomes 2 squared, because 2 times 1 is 2. This becomes, so maybe I'll write that, 2 times 1, this becomes x, 2 times 3, so this becomes 2 to the second power, x to the sixth power, which you can obviously change to this. So if there is a coefficient and it's raised to a power, you still have to do the power rule. So it very much looks like the distributive property. There are parentheses involved and you are multiplying. So if we had 3 to the second, x to the fourth, y to the third, and it's all raised to the third power, this would be 3 to the 2 times 3, x to the 4 times 3, y to the 3 times 3, which would be 3 to the 6th, x to the 12th, y to the 9th. Okay, so we just multiply whatever powers are in here by this power that's out here. Okay. It works also in this situation where we have a fraction or division going on within the brackets. Remember, that's 3 to the 1, so we would do 3 times 4 times 1, and we would do x 2 times 4, and we end up getting 3 to the 4th over x to the 8th. This can even happen when we deal with negative powers. So for example, if we do something like 2 to the negative 2, x to the 4th, y to the negative 3, and we raise it to the negative 2 power, we can do negative 2 times negative 2, we can do negative 2 times 4, we can do negative 3 times negative 2, right? Everything inside here is being, every power inside here is being multiplied by negative 2. So we end up with 2 to the 4th power, x to the negative 6th power, x to the negative 8 power, y to the 6th. And then because this is a negative power, we can, or we will, move it to the denominator. Okay. Which brings up something that maybe I should have talked about with negative exponents. What if I have 3 times y to the negative 6th power? This negative power tells me that I need to flip it down to the denominator. But what is the base for that power? And the base is that y. So that negative 6 only applies to the base. It does not apply to this 3. That 3 doesn't have a power. Well, it has a power. It has a 1 power right there. So, and that 1 power, because it's positive, means that I'm not moving it anywhere. It's going to stay where it's supposed to be, which is actually up in the numerator. So when we do this, the 3 stays put. It's the base that had the negative power that moves down to the denominator. So if I have x squared, y to the negative 9th, z to the negative 2nd, Well, x squared is a positive power, so that stays up in the numerator. Y to the negative ninth gets moved to the denominator. Z to the negative 2 also gets moved down to the denominator. And that's what it would look like when you're over, when you finish. So what happens when we have multiple properties going on at the same time? So suppose we have 2x cubed squared times 4x to the second to the fourth power. Well, kind of like order of operations, or absolutely like order of operations, we look at parentheses and then we do exponents, and we see, so we're going to do PEMDAS. So parentheses, is there anything going on in the parentheses that I can simplify? And there isn't. Now I've got exponents. I can do the power rule. So that would be, and that's also applied to the coefficients. So this is 2 to the second times x to the sixth times 4 to the fourth times x to the eighth. So I did exponents. Now all I've got is multiplication. So we're going to multiply and we're going to use the product rule. So we'll do 2 to the second times 4 to the fourth times, and then with the x's, we add their powers. So 2 to the second times 4 to the fourth times x to the 14th power. And then, of course, you can crank these out in your calculator, what 2 to the fourth times 4 to the fourth is. 2 to the second times 4 to the fourth. But the powers get added, okay? Let's look at another example. So how about this? We're going to do, again, if we think about this in terms of PEMDAS, is there anything inside the parentheses that can be simplified? Not really. So let's head to exponents. And so we got to deal with the powers. So we're going to use the power rule here. Multiply everything by that power on the outside. So we get 3 to the 6th power, x to the 18th power, y to the negative 6th power, times 3 to the negative 8th power, x to the 2nd power, y to the 6th. Now, all we have is multiplication, so we're going to do multiplication. 3 to the 6th times 3 to the negative 8th, they have the same base, so I can add their powers. So this would be 3 to the negative 2nd power. X to the 18th times x to the 2nd would be x to the 20th. Y to the negative 6 times y to the 6 would actually give us y to the 0, which we know is really 1. So negative power means it goes in the denominator. Positive power means it stays where it's at. 0 power means that it's equal to 1. So this would actually be x to the 20th over 3 squared. Okay. Let me give one more example. Let's see. Let's try this. 2 to the third, x to the fourth, y to the negative third, raised to the third power, divided by 2x to the third, y to the negative fourth, to the negative 2 power. So, again, if we think about PEMDAS, we're going to go with exponents first. So we're going to multiply every power inside by this power on the outside. Every power on the inside by this power on the outside. So we get 2 to the 9th, x to the 12th, y to the negative 9th, over, and we have 2 to the negative 2, x to the negative 6th, y to the positive 8. Okay? So we just did the power rule. Now we look for multiplication and there isn't any. In fact, what we have now is division. So we're going to divide now. So that means we're going to use the quotient rule. So we're going to do subtraction. So we'll have 2, 9 minus negative 2. Then we'll have x, 12 minus negative 6. And then we'll have y, negative 9 minus 8. That gives us 2 to the 11th, x to the 18th, y to the negative 17th. And then positive powers mean they're going to stay where they are, but negative power means this goes down to the numerator. So fully simplified, 2 to the 11th, x to the 18th, over y to the 17th. So that's the end of part 2, which dealt with the power rule and then using all of the rules together.